Hey there, this is lesson 17, Convergent Margins. Now we talk about convergent margins, and what we're referring to are destructive plate boundaries, where two plates are pushed together and collide. Depending on what type of plate we're talking about, whether it's oceanic or continental, that'll affect what type of boundary is created. If an oceanic plate is involved, you'll always have a subduction zone at a destructive boundary. And that's because, if you remember, oceanic plates they're thin and very dense, so they would have a tendency to subduct or go under another plate if they collide. And there are two ways that this can happen. An oceanic plate can go under another oceanic plate. And that is the situation in, say, the Aleutian Islands or Japan or the Philippines. The other option is for an oceanic plate to go under a continental plate. And that's the situation in South America in the Andes. And similarly in North America, along the coast of British Columbia, you have an oceanic plate undergoing or subducting beneath a continental plate. There are two characteristics of subduction zones that are always present, and that is an oceanic trench. Where the plate subducts, it pulls down right at that margin, and it creates a really deep trench in the ocean. They can be 10 to 11 kilometers deep, just like the Challenger Deep. That is the deepest ocean trench in the world at just about 11 kilometers deep. So you always get this trench feature in the ocean parallel to a subduction zone. The other feature that you always find with subduction zones are volcanoes. Now, one example is where oceanic plate goes under another oceanic plate. You get a chain of volcanoes in the ocean. And that's the case in Japan. The Japanese archipelago is caused for that very reason. If an ocean plate goes under a continental plate, that's classic Andean volcanism. And that's what created the Andes and that chain of volcanoes. It's the same thing on the coast of British Columbia. Subduction under a continent, chain of volcanoes. They're mostly dormant now, so we don't see them very often, but they're there. The second type of destructive margin is a continent-continent collision. And that's what happens where two tectonic plates with continental crust collide. Now the difference is that continental crust is thick and buoyant. It's not as dense as oceanic crust, and it has a huge trouble with subduction. So it basically doesn't want to subduct. So when they are pushed towards each other, one doesn't give way and go under. They sort of hit each other and slide over top of each other and mash up. And this has created some of the most dramatic mountain chains on Earth, the likes of the Himalayas in northern India and the Alps in Switzerland. So what causes this to happen? Why do the plates even move? Why are they tending to hit each other and pull apart and generally move about the surface of the Earth? Well, the short answer is we don't know. But there are some good theories, and the main driving factors are thought to be slab pull and convection currents in the mantle. Slab pull is the idea that when one plate subducts under another, the leading edge of it is falling, and so it'll tend to continue to drag the rest of the plate with it underneath as a result of gravity. So the second part is mantle convection, and that just means that where new rock is rising to the surface and creating new ocean crust, other rock has to be falling and replacing it. And so it creates these convection cells in the mantle, or at least that's the theory, and it's a good one. So next time we'll talk about constructive boundaries. We spent all this time talking about destruction and destructive boundaries. Let's move on to the constructive boundaries.